instrument is used for double-line block working in absolute block territory. It is simple, robust, and compact in design, approved by Commissioner of Railway Safety. To prevent irregular operations in any other manner, no opening or access to interior parts is provided with. Locking and sealing facility. SM key for prevention of unauthorized operation. A telephone. A bell push for exchanging bell signals. It shall also be clearly understood that the telephones provided with block instruments do not do away with the necessity for use of authorized code of bell signals. This instrument is cooperative type instrument. For dispatching a train from the sending station, all the operations are required to be done at the receiving end on request or information from the sending station. For operating the commutator, handle bell plunger has to be kept in pressed condition for rotating the commutator from line closed to line clear or train on line and vice versa. This satisfies the condition that the station master has to go through one or more definite moving operations on the instrument besides working the bell or plunger before he can grant line clear. Click on the buttons. Telephone is superimposed on the block bell line through an induction coil and a 1 mF isolation condenser. The condenser isolates the telephone circuit from the block bell circuit. The telephone handset is provided with a pressel switch. For listening, switch need not be pressed. For talking, switch has to be pressed. This arrangement saves the telephone battery consumption. For up and down lines. The instruments provided with the visual indicators separately for up and down lines to show the following three conditions: line closed, line clear, train on line. These indicators also serve as the current indicators. Bottom needle indicator pertains to train being received. Shows three positions during the operation of commutator handle at the same station block instrument. Top needle indicator pertains to train being dispatched, shows three positions during the operation of the commutator handle at the other station block instrument. Bottom indicator TCFK of receiving station and top indicator TG/TK of sending station are connected in series across the same line. The deflection of the needle depends upon the polarity on line. No current on line refers to line closed. Negative on line refers to line clear, and positive on line refers to train on line. Both top and bottom indicator coils have 140 ohms resistance and require about 17 to 25 milliamps current for operation. Bell plunger. This is threaded through the middle of the commutator. The metallic ring of this plunger rod bridge two springs, one in not pushed condition, another one in pushed condition. Both these contacts are used in bell circuit. Normal contact, that is, when plunger is not pressed, is used for receiving bell beat. In non-RE area, pushed contact is used for sending bell beat. Every time the plunger is pressed, positive of bell battery is applied on the line, completing the circuit through bell relay and earth at distant station, thus registering the bell beat at the distant station. Commutator handle. This is mounted below the bottom indicator in the bottom portion of the block instrument, with a bell plunger threaded in the center of it. It has three positions: line closed, line clear, and train on line. Every time, the bell plunger has to be pressed to turn the commutator handle. An arrow indicates the position of the commutator. It is free to be turned from line closed to line clear, line clear to line closed, line closed to train on line, train on line to line closed. Only when commutator has been turned from line closed position and not from line clear position directly or indirectly. The commutator is turned through 20 degrees from normal position to either line clear or train on line position. The commutator gets locked in train on line position when turned from line clear to train on line. SM key. To prevent unauthorized operation of the clock instrument, a SM key is provided on the front side of the instrument. When SM's key is taken out, the commutator gets locked in its last operated position, that is, either in line closed or line clear or in train on line. In this position, bell beat can be sent and received from the other station. Sealing arrangement. The nut and screw provided for fixing DLPI cover can be used for sealing. This proves that the instrument is intact and not interfered with. Double locking arrangement. Double locking arrangement is also provided to lock the instrument by the maintainer as well as by the station master as stipulated in SEM, so that without the notice of SM, the instrument could not be opened for maintenance or for attending repair. Lines or wires. This is a 3-wire, 3-position double-line block instrument. The indications for the up and down directions are controlled by 1 wire each, and the bell and the telephone are worked by the 3rd wire, earth being employed for return circuit. In cases of interference from extraneous current, a metallic return may be provided for the block lines leaving the bell communication to be worked by earth return. In RE area, it requires 2 phantom lines along with earth return and 2 pair of cable, one for bell code exchange and the other for block telephone. 1 phantom for top indicator, 1 phantom for bottom indicator. 1 pair for telephone, 1 pair for bell, A 150 Hz oscillator feeds the line for bell working. This in order to avoid the time lag in DC bell code transmission. Commutator pin. Bell plunger is attached with a commutator pin which is normally engaged with the back of the front cover plate and prevents the commutator handle from being turned. Thus, the commutator handle cannot be turned from one position to another unless the bell plunger is pressed. Single-stroke bell will be actuated at the other end and draws the attention of SM whenever the commutator is turned. Commutator. To bring line clear indication in the bottom indicator of that instrument and the top indicator of the interconnected instrument, the commutator handle is turned clockwise through about 20 degrees from normal. Line closed. It is turned anti-clockwise through 20 degrees from the mid position to get the train on-line indication in the respective indicators. Commutator segments and contact springs. A fan-shaped ebonite plate is attached to the commutator disc. This plate carries 4 commutator segments in the front and 1 segment in the rear. There are 6 commutator springs mounted in front and 2 in rear of the commutator segment bearing plate. In the line-closed position of the commutator, the contact segments are free of the commutator springs. The first and 6th springs, as seen from the back, are connected to earth. The 3rd and 4th springs to the line, the 2nd spring to battery positive, and the 5th spring to battery negative. When the commutator is turned to line clear position, the top contact segment on the left, as viewed from the back, puts through the battery positive to earth and the bottom segment, or the right connects battery negative to line. This negative polarity is connected to line through the bottom indicator of the instrument. This brings line clear indication via the bottom indicator at the advanced station and the top indicator of the rear station instrument. When the commutator is turned to the train on-line position, the top contact segment on the right connects battery negative and earth springs, and the bottom contact segment on the left connects battery positive and line springs. Thus, the polarity to line is reversed, and the indications of the indicators of the 2 instruments of the section also change to train on-line. In the train on-line position of the commutator, the rear contact segment on the left puts through 2 other springs in rear. This special contact is included in the block clearance circuits. Spring-loaded ball mechanism. The commutator disc moves over a spring-loaded ball at its bottom, which gives easy movement to the commutator. This mechanism helps commutator to reach exact line closed, line clear, and train on-line positions when it is being turned, prevents sluggish operation of commutator, and helps in making the spring contacts at the proper position of line clear and in TOL, which is very essential. Door lock assembly parts. Click on the buttons. Door lock assembly. This is an electromagnetic device mounted centrally just above the commutator disc. It is free to be turned from line closed to train on line. Line closed to line clear. Line clear to line closed. Train on line to line closed. Only when commutator has been turned from line closed position and not from line clear position directly or indirectly. the commutator gets locked in train on-line position when turned from line clear to train on-line. The door lock coil mechanism prevents locking of block handle in train on-line position when turned directly from line closed position to train on-line position, and thus facilitates block forward and block back operations without failure of block working. The mechanism economizes the power consumption of door lock coil by holding the armature mechanically once the door lock is energized momentarily. The displacement of holding pole distinctly proves whether the block handle was earlier turned to line clear position or not in case of any dispute. When the conditions of lock and block are fulfilled, the door lock coil is energized and its armature is lifted out of the notch, which in turn lifts up the releasing bracket, thus pushing the releasing lever upward. This removes the obstruction at the holding pin, as a result of which the holding pole swings back to its normal position below the armature and is now ready to catch the later when it drops down. The commutator is now free to be turned from train on-line to line closed for bell unit front view. Click on the buttons. Bell unit back view. Click on the buttons. Bell unit inner view. Click on the buttons. Bell unit. The bell unit is made of cast iron body. A bell gong is fixed on the top of the bell unit. It consists of bell relay, bell coil, and termination blocks. Bell coil. The bell coil is energized through the pickup contact of ball relay. It has 60 ohms resistance and requires about 85 milliamperes to register a bell beat. Bell relay. The bell gong is a single-stroke bell worked by a relay called a bell relay. The resistance of bell relay is 500 ohms and requires a minimum operating current of 75 milliamperes. The relay and bell form a separate unit. The bell relay is worked by a separate line wire. RS 31/80 is included in series with a top indicator to control the last stop signal and fulfill the requirements of absolute block system. The relay has one arm with 3 positions. When there is no current flowing through the relay, the arm remains in the center. The relay resistance is 77 ohms and requires a minimum operating current of 15 to 16 milliamperes for its operation. The normal working current is 25 milliamperes. Polarized relay not conforming to IRS 31/80 should not be used. SGE type bicolor make. Contact arrangement in SGE type bicolor make are: line closed, does not make any contact, line clear, 1 and 2, 4 and 5 make, train on line, 2 and 3, 5 and 6 make, as well as the special train on-line contact 7 and 8 makes. IRS type Howrah make. Contact arrangement in IRS type Howrah make are line closed, no segment makes. Line clear, 1 and 2 segment makes, that is positive to earth. 8 and 9 segments makes, that is negative to line, and 4 and 5 makes, which is pair contact. Train on line, 1 and 9 segments makes, that is negative to earth. 7 and 8 segments makes, that is positive to line. 3 and 4 and 5 and 6 segments makes. 3 and 4 or 5 and 6 is used for block clearance circuit and another is pair segment. SR type PTJ make. Contact arrangement in SR type PTJ make are line closed, 11 and 12 makes. Line clear. One and 2, 5 and 6 makes. Train on line. Three and 4, 7 and 8, 9 and 10, and 11 and 12 makes. Differences between the three types of DLPIs are as follows. Contact arrangement of bipolar make has a butterfly type commutator. Contact arrangement of Howrah make has 9-way drum type slotted segments commutator. Contact arrangement of Bodenur make has a 6-way circuit controller commutator. Telephone and bell set of bipolar make and Howrah make are provided externally in separate housing, whereas telephone and bell set of Bodenur make is provided internally in one housing. Polarized relay of bipolar make and Howrah make are provided as a pair of instrument externally, whereas polarized relay of Bodenur make is provided as a part of instrument internally. Door lock mechanism arrangement of bipolar make and Howrah make is mechanical stick, but door lock mechanism arrangement of Bodenur make is electrical stick. Differences between the coil resistances and working current of the three types of DLPIs are as follows. Resistance of door coil or TOL lock coil of bipolar make is 50 ohms. Howrah make is 14.8 ohms and Bodenur make is 48 ohms. Working current of door coil or train on-line lock coil of bipolar make is 200 milliamperes. Howrah make is 250 milliamperes and Bodenur make is 250 milliamperes. Resistance of bell relay of bipolar make is 500 ohms. Howrah make is 400 ohms and Bodenur make is 400 ohms. Working current of bell relay of bipolar make is 20 milliamperes. Howrah make is 25 milliamperes and Bodenur make is 25 milliamperes. Resistance of bell coil of bipolar make is 60 ohms. Howrah make is 30 ohms and Bodenur make is 48 ohms. B are two stations on double line. To dispatch a train from station A to station B, following operations are performed. A and B exchanges necessary bell code signals for attending the telephone, and the information is exchanged between A and B through telephone about the dispatching train. A gives line clear signal to B by bell code with 2 bell beats by pressing bell plunger. B acknowledges line clear signal and turns the commutator of his block instrument to the right by 20 degrees. This changes the indications of the lower needle at station B and the top needle at A into line clear. A, on observing the upper needle in its instrument, now pointing to line clear, takes off the last stop signal LSS for the train to start. When the train passes the last stop signal, that is, on entry of train into block section, A sends train entering signal to B. B acknowledges train entering into block section signal and turns the commutator of his block instrument to the left by 40 degrees, indicating train on line on lower needle at station B and upper needle at station A. A restores the LSS lever to normal. B takes off the home signal. On arrival of the train into the station, puts back the home signal which has been automatically replaced to on. B verifies the complete arrival of train and puts back the home signal lever to normal. Thereafter, gives train out of section signal and turns the commutator to line closed position. A acknowledges the train out of section signal. Line block instrument requires following supply for its working in non-RE area. Block needle battery 9 volts plus line drop. Bell battery 6 volts plus line drop. Telephone battery 3 volts to 4.5 volts. Local battery 12 or 24 volts. Double line block instrument requires following supply for its working in RE area. Block needle battery 14 volts plus line drop. Telephone battery 3 volts to 4.5 volts. Local battery 12 or 24 volts. Block battery and bell battery shall be separate for each block instrument. No other circuit and/or circuit of other block instruments shall be fed from the block battery. Block signaling is a system wherein the passage of trains electrically controls the block of instrument, which in turn electrically controls the both side signals of a block section. Each DLPI, a separate earth should be provided for indication circuit and bell or telephone circuit. Earths shall be provided as per approved drawings. As far as possible, the earthing arrangement shall be located in the natural soil. Made-up soil, which is not consolidated or is likely to be eroded by weather, shall be avoided. Earth electrodes shall not be buried in a position likely to cause an obstruction or where it is likely to be damaged. Arrangement normally consists of one or more galvanized iron pipes of not less than 38 mm internal diameter and not less than 2.5 meters in length, with spike at one end and a lug at the other for connecting the earth-led wire. Alternately, GI steel rods of not less than 16 mm diameter or copper rods of not less than 12.5 mm diameter, not less than 2.5 meters in length, can be used. There is no necessity to use electrodes of more than 3 meters or 3.5 meters in length, as the decrease in resistance is only marginal. When a rocky soil is encountered at a depth of less than 2 meters of the length of the electrode may be buried inclined to the vertical, the inclination being limited to 30 degrees from the vertical. The length of the earth wire shall not be as short as possible. The earth wire shall not have a sharp bend or spiral. Asphalt or concrete cover of about 50 mm thickness around the earth for a radius of 1 meter to retain the soil moisture is desirable. The resistance of the earth shall not exceed 10 ohms. More than one earth is used, the distance between earth pipes shall not be less than 3 meters. The conductors leading to these earths shall be electrically insulated from each other throughout, and also from metallic structures connected to different earths. There shall not be any possibility of simultaneous human contact with metallic bodies connected to different earths. The minimum clearance of equipment earths from system earths provided by the electrical department either of the railways or of the other administrations shall be 20 meters. Earth connections shall be carefully examined and kept intact and joints soldered. Earths shall be regularly watered. The supervisory, SE or SSEs shall examine block earths and their connections at intervals of not more than 3 months. Block earths shall be tested for resistance at intervals of not more than 12 months by the sectional JE or SEs or supervisory SE or SSEs. Where the resistance exceeds 10 ohms, action shall be taken to reduce the resistance by providing additional earths in parallel. The purpose of the block bell circuit is for call attention and give prescribed bell codes relevant to train operation. At station B, the bell plunger is pressed. At station B, the current flows from positive of the battery to bell spring contact 2 to 3 and on bell line to bell plunger, not pressed contact P1 of station A. It reaches earth at station A passing through the bell relay coil. Then flow to earth at station B and reaches bell battery negative. At station A, bell relay picks. The single-stroke bell coil energizes, the armature is attracted. A hammer is connected to the armature, which moves and strikes the bell gong. And the bell rings at station A. The purpose of the indication circuit is to inform train sending and receiving station the status of the train, that is, line clear, train online or line closed. At station B, station master turns the block handle to line clear position. Current flows from indication battery positive to commutator spring B positive through line clear segment through spring T3 to earth of station B. Current reaches earth of station A and flows to polarized relay coil R1 and R2 to top indicator coil R1 and R2 to block line. From block line at station B to terminal BL1 to bottom indicator coil R1 and R2 to commutator spring T5 through line clear segment to B negative spring to indication battery negative terminal. At station A, polarized relay tongue contact attracts towards LC. Top indicator at station A and bottom indicator at station B shows line clear indication. At station B, when the commutator handle is turned towards train online from line clear, the commutator handle gets locked in train online position. The current flows from battery positive to B positive spring through train online segment to T4 spring to top indicator R1 and R2 coil and to polarized relay coil R2 to R1 and to earth at station A. From station A earth to station B earth to block terminal T6 spring to train online signal to B negative spring and then to indication battery negative. At station A, polarized relay tongue contact attracts towards train online. Top indicator at station A and bottom indicator at station B shows train online indication. Station master ensures complete arrival of the train at station B and turns the block handle to line closed position from train online position. Relays SR1 and SR2 are normally in the energized condition. The front contact of these relays is provided in the LCPR and LSSDR circuits. when line clear is granted from station B by operating the commutator to line clear position, the PR is operated to make line clear contact at station A so as to complete the LCPR circuit. Now, when the LCPR front contact and the lever of LSS is reversed through the lever reverse band, the green aspect control relay LSS DR picks up. Note 1. In this circuit, the LSS DR back contact and LSS normal band are bypassed by LCPR front contact to ensure that LCPR is held through its own front contact when the LSS is taken off. Note 2. The LCPR front contact is bypassed by DECPR front contact of LSS. DG is to ensure that once the LSS is taken off on proper line clear, it cannot be replaced to on by any interruption to PR due to line break or mismanipulation of commutator at station B, that is, to avoid LSS becoming a danger in the face of an approaching train. Note 3. The reverse band of LSS lever is incorporated in both the positive and negative limbs of DR for double cutting, and normal band across the relay is to effect cross protection. Train enters block section, actuates FVT track. LSS signal goes back to on. Station master A gives bell signal to station master B. Station master B acknowledges train entering bell signal and turns the block handle to train online. PR relay attracts towards train online contact. On arrival of the train at station B, station master ensures complete arrival of the train and turns block handle to line closed position. Train passed home signal and on AD track, ATPR dropped. The current fuse flows from fuse to up ZR3 back contact to ATPR back contact to BTPR front contact to home signal lever 3 reverse band to up ZR2 back contact to up ZR1 coil R1 R2 to negative up ZR1 held by its own front contact. Train clear AT track and on BT track, ATPR up and BTPR down. Current flow fuse to up ZR3 back contact to ATPR front contact, BTPR back contact, up ZR1 front contact to up ZR2 coil R1 R2 to negative. Up ZR2 held with its own front contact. A bell rings along with an indication to turn the block handle to train online in case it is not turned before, when the train entered into the block section. Block handle turned to train online. Current flows from fuse to train online contact T1 T2 to up ZR2 front contact to up ZR3 coil R1 R2 to negative. Up ZR3 held by its own front contact as long as block handle is turned to line closed position. Since train online contact T1 T2 is broken. Current flows from fuse to all the back contacts of 3x4 DECR, 3x4 HECR, 3x4 UECR, 3x4 DR, 3x4 HR, up ZR1, up ZR2 to front contact, up ZR3 to normal band of home signal lever 3 and normal band of home signal for bell plunger pressed contact to commutator lock coil R1, R2 to negative. The home signal lever or station master slide normal commutator lock energized and armature is in held position. Station master turns block handle from train on line to line closed position, ensuring complete arrival of the train. Instrument shall be checked for the following: free from mechanical damage, corrosion. All nuts and bolts shall be secure and complete. The wiring shall be checked for the correct connections and proper dressing, sealing. All the external connections of the block instrument shall be removed and insulation resistance measured between individual insulated circuits and earth. The minimum value between each individual insulated circuit and earth shall not be less than 10 megaohms. Check that the line clear can be granted only when reception signals are proved at on. Check that the circuit for proving the arrival of a train is directional. The instrument shall be kept at a raised level. The instrument shall be mounted level. The instrument shall be so placed as to have an easy access and space for their maintenance. The instrument shall be securely fixed on a sturdy table. For woodwork, use spirit polish. For metal casing, use green enamel. End cabin working. Instruments are placed at respective side of end cabins. Centralized cabins, root relay interlocked or panel interlock stations. Instruments are provided at the central location or SM room. Line wires shall be used between the terminating point on or near the station or cabin and the point where the lines of two adjacent block sections meet in case of central location. The insulated wires shall be terminated on pothead insulators and not easily accessible. The wires leading into the building from the terminating point shall be adequately separated from the wires of other circuits. The wires shall be run in one length from the pot-headed insulator to the test panel. Alternatively, a cable suitably protected may be used, but a separate cable shall be provided for each instrument. The indoor wires shall be run in troughing, grooved board, or piping, or suitably protected from outside interference and separated from the wires of other circuits. All wires or cables shall be in accordance with the Indian Railway Standard Specification or other approved specification. Lightning dischargers shall not be located in the block instruments but installed separately and shall be the demarcating point for test purposes. Quick-acting relays shall not be used for stick circuits of the block instrument. Only shelf-type relays or alternatively two immunized plug-in type relays connecting in tandem shall be used. Block release shall be by the operation of the two-track circuits sequentially. The commutator handle is locked first before the train on-line indication appears on the indicator when the handle is turned from line clear to train on-line position. Check that the block clearance relay QR or ZR picks up only when the commutator is turned to train on-line position. Check that the last stop signal cannot be taken off when the commutator is in other than line clear position and the train has entered the block section. Check that the last stop signal is automatically replaced to on when the train enters into the block section and continues to remain in the on position until the train has arrived at the receiving station and a fresh line clear is obtained. Check that when the commutator is turned from line closed position to train on line position, the commutator is free. Locking arrangement on back cover. Ensure that sealing is intact. Check that SM's key is effective and commutator gets locked in its last operated position. Check for the correspondence between commutator handle and indicator except where auto train on line feature is provided. Check single stroke bell for its efficient functioning. Check door lock assembly for perfect working, including four-strop arrangement. Check full notch and half notch on locking plate. They should be correctly shaped and are in square. Holding pin is not worn out. Full notch should be square and half notch should be beveled. Check that sealing of polarized relay is intact. Check all springs for proper tension. Check line battery and telephone battery voltage and also measure the working current of block instrument and compare with the standard value. Ensure that LSS cannot be taken off without obtaining line clear from receiving station. Ensure that LSS assumes on aspect automatically when FVT is occupied by first vehicle and it could not be retaken off again on same line clear. Ensure that commutator could not be turned back from train on line to line clear position when turned from line clear to train on line directly, unless the train sequentially operates the two-track circuits and, after the passage of train, all reception signals have been put back to on. Check wiring of instrument. No loose wires get entangled in the moving parts. Measure earth resistance. Value should not be more than 10 ohms. Electrical or mechanical locks are in a condition that they are not liable to be forced. Needle indicators must be properly maintained so that they operate fully and return to the normal position when the commutator is brought to line closed position. It should be ensured that the commutator movement is smooth while turning it from one position to another position. It should be ensured that commutator gets locked when it is turned from line clear to train on line position before train on line indication contacts are made. See that all terminal screws, nuts, lock nuts and locking screws are tight and all split pins are opened. Inspect the contact surfaces on the butterfly assembly. If pitted, clean them with chamois leather. All springs are in good condition and kept properly adjusted. Check the resistance of indicator coil, lock coil and their working currents. If considerable difference is noted between subsequent readings, locate the fault and rectify the same. Check the full lock notch and half lock notch on the locking drum for their correct shape and squareness. Correct them if necessary. Check that no loose wires get trapped in the moving parts. Check that only correct springs make when commutator is in line clear and train on line positions. Check that the desired springs make when bell plunger is pressed and the bell beats are registered properly when bell plunger is pressed by the adjacent station. Check the coil resistance of bell relay, bell coil and their working currents during inspections. If considerable difference is noticed between subsequent readings, locate the fault and rectify it. Check the telephone battery, replace if necessary. All batteries must be kept clean. Terminals must be free from dirt and corrosion. Ensure that for same block instrument, batteries for indication and bell circuits are separate. Indication battery for two block instruments of adjacent section at a station should also be separate. Ensure that wire connection at the terminals are firm. All wiring is in good condition and free from joints wherever necessary, are properly soldered and insulated. Block instrument telephone, its flexible cord, and the condenser or other means provided for isolating the telephone from the block instrument circuit are in good condition. The isolation is such that there is no direct path for the current to flow from one circuit to the other. Receiver diaphragms are not buckled and are at the correct distance from the pole pieces. Receiver earpieces fit correctly and are screwed tight. These shall be checked once in a month by the sectional JE or SEs and once in 3 months by the supervisory JE or SC or SSEs. The sectional and supervisory engineers shall check at intervals not exceeding 3 months the wiring of the instrument to see that the insulation is in good condition. Any wire peeled off or damaged, insulation shall be immediately changed. Be regularly watered. Check and ensure that lightning and power protective devices, earth and earth connectors are effective and in good condition, and joints, if any, are soldered. Ensure that common earth is not used for indication circuit, because in case of leakage or breakage of one earth, both the instruments will come in series. In case of train online position, positive will be online and negative on earth from the line battery. At that time, for another line clear, the negative will be online and positive on earth. During this period, if earth breaks, PR, polarized relay, may attract to train online position and a PD, potential drop, is created. If the value of PD is more than 5 volts, PR will attract to line closed position when a train is in the section. This enables the last stop signal to be put off for second train, which is unsafe. Hence, common earth should not be provided. The supervisory SE or SSEs shall examine block earths and their connections at intervals of not more than 3 months. Periodical overhauling interval shall not exceed 7 years for double-line block instruments. The associated polarized relay shall also be overhauled along with the block instrument. It shall be ensured that vital parts of the instrument, like door lock mechanism, spring contacts, etc., which undergo wear and tear, are replaced invariably at the time of overhauling. To check the block instrument terminal screw of LC, TOL segments for proper tighten. Do check the connecting wires eyelet. Do check the springs and contact segment for proper contacts. Do check the block line connection. It may have dry soldering which offer high resistance. Do check the earth resistance regularly. Do check the line, bell, telephone and local battery regularly. Do check that block handle gets locked in TOL, half notch when turned from line clear to TOL before TOL indication circuit is energized. Do check for residual magnetism in lock coil and interchange R1 and R2 terminals to notify residual magnetism. Open the cover of block instrument without the written permission of station master. Do not open the cover of block instrument without giving disconnection memo. Do not open the cover of block instrument to attend for maintenance or failure when the train is in the block section. Do not forget to lock and seal the block instrument when work is completed. Do not give more pressure or bend the contact springs. Do not oil the needle, coil and wipe the oil completely. Do not file the lock notch as well as half notch, as the edges may get rounded off and result in unsafe failure. Do not connect both instruments to common earth. Do not connect common both upline and downline indication circuits to common earth. Do not connect indication and bell circuit to common battery. Double-line block instrument is simple, compact and robust in design. It requires simple maintenance and a scheduled overhauling. A thorough periodical overhauling in the workshop is necessary for the efficient working of the double-line block instrument. This periodic overhauling of the block instrument shall not exceed 7 years. Tension gauge, multimeter, hydrometer, cutting plier, nose plier, screwdriver, megger. Filter of an approved design shall be used between the block instrument and line wire. It is essential that the line and block instrument terminals of the filters are never interchanged. The block filter is a low-pass filter consisting of series choke coils S1 and S2 in each line and the shunt condenser C1. The condensers adopted are 4-terminal condensers to provide the continuity of condensers forming the condenser. Also, 2 gaseous-type lightning arresters with a flash voltage of 150 volts are provided on the line side for high-voltage protection. This satisfies the condition that the station master has to go through one or more definite moving operations on the instrument besides working the bell or plunger before he can grant line clear. The block of last stop signal. Check the needle indicator for line clear indication. Line clear indication is OK. Check whether the LSS DR is energized or not. If DR is energized, then check the LSS lamp circuit, AC 110 supply, fuse, outgoing supply at terminals, signal transformer, lamp holder and lamp. If DR is not energized, then check whether LCPR is energized or not. If LCPR is energized, check the LSS lever R band, SMYR and DR circuit contact by contact. If LCPR is not energized, check whether SR is energized or not for the previous operation of block handle in TOL position. If SR is energized, then check up the PR relays and LC contact making properly. If it is OK, check LCPR circuit, otherwise check PR relay and replace. If SR is not energized, then check the SR relay circuit wiring with handle at advanced station in TOL position. Line clear indication is not OK. Check the line voltage on 1.2 of indication line. If the voltage is OK, then check the TGT coil for dry solders and the DC voltage on PR. If it is OK, then replace the defective TGT coil, otherwise check the internal wiring of TGTK, PR and earth connections. If the voltage is not OK, then check the voltage on derivation cable. If incoming voltage is available, then check the filter unit right. If the incoming is not available, then check at station in advance for failure of lock on commutator. Check if the ZR is picked up or not. ZR is picked up. Check for electrical failure. Local battery low voltage. Commutator lock coil defective and dry soldering in coil lead connections. Check for mechanical failure. ZR is not picked up. Check up ZR circuit including stick feed, fuse, TOL or LB contact and home signal lever bands, etc. Failure of bell beats. Check for mechanical holding and electrical holding. No bell beats. Observe the incoming tone with plunger pressed at other station. Bell beat is OK. Check voltage on bell relay. Bell beat is not OK. Check the other station instrument, press plunger and check the relay inside the block bell equipment whether it picks up or not. If the relay is picking up, then check the bell relay contact. If the contact is OK, then the oscillator is defective. If the relay is not picking up, then check the fuses in block bell equipment, the plunger contact and resistance.